Okay, so here's a vector problem where we are given a position vector. We need to find the time the particle is southeast of the origin. And then we need the speed of the particle at this time. So first thing, if we think about it being southeast, let's think about a compass. So there's north to south, there's west to east. And let's annotate them. So north, south, west, and east. So if we want southeast, we need it to be exactly in the middle of those two. So that means southeast. East means that I is positive, and south means that J is negative. So to be exactly southeast, that means that I has to equal minus J. So the same but different signs. So we are given the 4t minus 3 over t plus 1. So this is our I and this is our J. So that means that I for t has to equal the negative of J, which is already a negative. So that means this becomes a positive. So now we want to find time, t. So we'll multiply through by the denominator. So we've got 4t times t plus 1 equals 3. And then we'll turn that into quadratic. 4t squared plus 4t equals 3. So 4t squared plus 4t minus 3 equals 0. And then we'll solve that quadratic, which gives us t equals minus a half. Okay, so that's it. So basically we find out that the time of the particle is t equals a half. So that's part A. Now part B, the speed of the particle at this time. Well, we have got a position vector. Remember that position, velocity, acceleration. Okay, if I want to get from position to velocity, I take the change in displacement over time. If I want to get from velocity to acceleration, the change in velocity over time gives me acceleration. So what I need to do is differentiate my position vector. So y, or actually we should call it r, r equals 4ti minus 3 over t plus 1. Okay, well, let's rewrite it to make it easier to differentiate. So r equals 4t times I minus 3t plus 1 to the minus 1j. Okay, so then that means that if we do dr by dt, this becomes 4. So I've got 4i. And now if I differentiate this, I've got minus 1 times minus 3. So now I've got 3t plus 1 and minus 2, and that's my j. Okay, so that's my derivative. And now all I have to do is substitute in my t. Well, we found that t was equal to half. So I've got 4i, no t component, plus 3 times g, which is a half, plus 1 squared. Okay, so that means I've got 4i plus 4 over 3j. Now, remember, this is basically a velocity vector because I've differentiated a position vector. So this is velocity, but I want speed. So now remember that velocity is a vector, so that has an ij component. Speed is a scalar. So what I'm going to do, I'm going to basically take the magnitude of 4 squared plus 4 thirds squared. When I do that, I get 4.22 meters per second. That is my final answer for B.